So, we are going to talk about this particular example of compound interest with the help of this example. So, let's read the question and then we can talk about it. It says Peter has $100,000 and he is looking for a good investment opportunity. He has the following options. First is buy a piece of farmland, grow carrots, and sell at the end of 2 years for $110,000 after all expenses. That means sell the farmland and carrots and everything at the end of 2 years for a total of 110k after all expenses of crop growing and selling and everything. Or second option is deposit the money in a bank account paying 5% interest. So what should Peter do with his money? And this is an example of a compounding of money that we are going to talk about, which is basically saying that when you put the money in a bank, the money grows at a certain interest rate, but at the end of, let's say, first year, assuming that the interest is paid annually, at the end of first year you will get some interest, and at the end of second year you will get interest on that interest. So that's the point that we are trying to emphasize through this example. So the first option is simple. Let's talk about it. So option 1, let's talk about total profit. Total profit, this is straightforward, is total sell price minus investment, which is 110k minus 100k dollars, which is $10,000. Sorry, $10,000. So option 1 is straightforward. At the end of 2 years, he will have $10,000 of profit after all the expenses are paid. Let's talk about option 2. So this is not so straightforward because we need to calculate it. We cannot just do a simple subtraction here. So we are given that 5% interest rate. That means if I deposit $100 in the bank, and assuming that the interest is paid annually, that means every year, then I'm going to earn $105. I'm going to get a total of $105. That is my principal plus interest at the end of 1 year. There can be sometimes semi-annual interest payments or even monthly interest payments, or there are more advanced concepts like continuous compounding, which we are not going to talk about, but the concepts are similar. If it is semi-annual, then you are going to be given 2.5%, that is half of this 5% every 6 months. So that changes the calculation somewhat. For the purpose of this example, we are going to assume that this 5% interest rate and interest is paid annually. That means at the end of 1 year. So total money versus time. Let's make a small table like this. This is our this will help us make this decision. So when time is 0 years, that means at the start, the total money is 100k. I'm just going to write 100, but we know that it is $100,000. At the end of 1 year is going to be $105, $105k, because it's 5% interest, which is 100 was your starting value plus 5% interest, so that is 105. And at the end of 2 years, now this is somewhat tricky. It is going to be 100 times 1.05 plus 5 times 1.05, because we got $5 or 5 in this example $5,000 worth of interest, and even that interest is now going to start accruing interest. So it is going to be a total of, so at the end of 2 years, total money is 105 times 1.05, which is 100 times 1.05. This is on principal growth plus 100 rather 5, which was the interest at the end of 1 year, times 1.05. Forget this. This is the interest growth. Which happens to be 100 times 1.05 is 105. This is no coincidence. The number has to be 105 because that is the simple interest at the end of 1 year. Plus 5 times 1.05 is going to be 5.25, which is 110.25 K dollars. That means these many $1,000, which is 110,250 dollars. So let's compare what happened in the first case. This was a total benefit, or the total profit was $10,000, whereas in the second case, so total profit is your total final amount 110,250 minus 100,000. That's your starting value, which is $10,250. So it's clear that it's better to just invest the money in the risk-free bank account, because investing in this farmland and growing carrots and getting a total of $10,000 of benefit is not as much valuable as investing your money in a bank and getting risk-free basically, and even hassle-free profit of 10,000 plus $250. And that's the power of compounding, that your interest also starts gaining interest, and the interest on that interest will also start accruing interest, and so on. So in general, if you have, let's say, suppose your principal, the starting value is P, and rate of interest is R, let's say per year. This is R is a fraction here, so this can be R is 5%, is 0.05, etc. And so suppose then after n years, your total money is equal to P times 1 plus R raised to n, and this n in the exponent is the power of compounding, really, that for small values of n this is non-significant, but if your n is 10 or 20, then this 1 plus R to the power n can really grow the money a lot. And in this example, as we demonstrated, that it is not just that the principal is growing in the second year, but also your interest. And so that's why it's better in this particular example to just grow the money in the bank. Just deposit the money in the bank and get a 5% interest. The numbers would change, of course, if the assumptions are changed. So instead of at the end of 2 years, if you're going to get not $110K, but if you're going to get $112K, let's say, then just a simple analysis like this may or may not be straightforward, because there are other factors then, because there is always a small risk that you will lose your farmland to not lose a farmland, you might lose your crop to some unexpected weather, or the payoff may not be as much as you expect, and so on. So there is always that risk. But whereas there is in the bank, it's almost essentially risk-free investment. So then we'll have to take into account the risks associated with the two options. But if the bank is paying more with this compounding of interest, then it's not even a competition. You just have to invest in the bank. Or in other words, the farmland is not as profitable. It's not a worthwhile exercise at these levels of return. Okay, that's about it.